on a stage. Okay, you have already started the meeting. Hello, good morning, everyone, and welcome to this webinar of INCIT-EV project. This is the first of a round of webinars that will take place until the end of the project that will end in June 2024. So we are pleased to welcome you on board today for the final outcomes that we have received in this project. Let me briefly introduce. My name is Miguel Farfuela. I'm project manager at FIRFE, and I'm coordinator of this project in INCIT-EV that is taking part of the webinar series that is starting today. Today's agenda will include some of the partners of the project, and we'll be able to focus on smart and V2G charging, that, as you know, is a very hot topic in the recent days in Europe. We will start with a presentation of the short presentation of the project. Then we'll have a first round of panelists, starting with Total Energies, with Bram van Eijsden. Bob Elders. Unfortunately, Bob is ill today, so we only have Bram in this time slot. Then we'll continue to the bidirectional charging panel that will be presented by Widai Solar and FIRFE. This will be involved in the comparison of bidirectional charging under AC and DC. And then we'll have this panel discussion with the automotive industry. So we'll have representatives from Stellantis and Iveco and all the previous panelists. So we'll be able also to receive your questions via the comments of this webinar. So all the panelists will have some times after the presentation or during the debate to answer your questions. So without using additional time, as we have a tight schedule for the next 1 hour and a half, we will start this nice webinar on new smart bidirectional charging topics for EVs. Let's start first with the short introduction for INCIT-EV project. INCIT-EV is a project funded by the European Commission. It started in 2020 and it has an overall budget of almost 19 million euros. It will end in June this year. So we have run this project for a little bit more of 4 years. And at this point, we are able to share with you all the outcomes of the project. This project, which is coordinated by FIRFE, comes with more than 30 European partners, and then the main objective is to develop a set of charging technologies to be validated in 5 European countries. In general, we are covering 3 topics: smart bidirectional charging, as we'll have today the introduction of the demo site based in the Netherlands. We have also a topic of the project related to inductive charging, so wireless charging on static and dynamic. And also we are working in different charging possibilities of fast charging, but also controlled by the TSO and the DSO to allow more flexibility and resilience in the grid. Here you have a picture of all the partners of the consortium. As you see, it's a large consortium, and we have some of them in the webinar of today. Let me just briefly introduce what we have done in this project. This is a project focused on EV users. So the final aim is to know what are the problems and the expectations amongst EV users to develop these technologies that will foster the the EV market and will ease the charging methods and the charging systems in order to be more interoperable for the users. We started the project with some information from the users, and we have developed the technologies in regard with this information. We are also developing a decision support system for mobility planners that will be presented in a next webinar, in which we can optimize the charging points in a city, knowing the existing EV fleet, then the EV fleet that is expected to be available in the next years. So we can, according to the grid, establish what number of charging points we need in the city. We are also developing a set of wireless charging demonstrators. We'll have in Paris 2 electric roads that will be able to charge up to 100 kilometers per hour and 90 kilowatts in motion. And we are also developing a set of chargers that allows smart charging algorithms, and bidirectional charging. At the end of this project, we are also going to release the economic numbers for the CapEx and OpEx of this infrastructure. So we'll know the business models of each of the technologies. I will just want to share this will be a topic of the next webinars. So if you still hear from INCIT-EV, will be interesting, as next webinar will be based on inductive charging. So we will able to showcase the results from the pilots that we are developing. In this case, this one is in outskirts of Paris. So feel free to follow our project. So new information about these demonstrators will be available soon. Before I will pass the turn to our panelists of today, I would like also to inform you that we are planning a final event in the 26th of June. I will be in Paris, and remote and in-person attendance will be possible. The registration are open, so you can still register, and depending on the availability, you will be able to join in person or remotely. Before I pass the word to Bram, that will start with the smart charging, I would just like to highlight this situation from last weekend, in which we had negative prices around all Europe. But this, for example, is the information of this Saturday at 13 hour at 1 p.m. But 6 hours later, we had a change of more than 100 euros per megawatt hour. So that means that more and more, and especially now in the spring, we are having times with high renewable generation and with lower cost, and then times with higher cost and lower renewable generation. Therefore, this is just to start up the debate and to see how EVs can contribute to solve the solution and to reduce the cost for the final users. I will not use any additional time, so I would like to introduce Bram van Exden from Total Energies. He's part of the project and will introduce use case 1 based in the Netherlands. Bram is responsible for smart energy solutions, including smart charging technologies and Total Energies network of charges in the Netherlands. He's been working in e-mobility since 2012, and he will be in this panel. Unfortunately, Bob Elders from Greenfalls is ill today, so he will represent this panel today. So Bram, the floor is yours. You can share your own screen, and you can start.
Thank you very much, Miguel, for this introduction. I will start sharing my screen. can you please confirm that it's going well?
Yes, it is.
Perfect. Thank you very much. So yes, today, in briefly, in about 7.5 minutes, I will tell you something about use case 1, use case 1A. More specifically, use case 1A is part of work package 7. It's covered by Total Energies and Greenflux. As Miguel mentioned, unfortunately, my colleague Bob is ill today, so I will cover the presentation. And yeah, I would like to start immediately. To introduce, grid congestion in the Netherlands is quite a hot topic. On the left, we see a map of the Netherlands, which shows you where congestion is active. And yeah, as you can imagine, the red parts are parts where no new grid connections are available for customers. Orange parts are areas where new connections are available only if you apply some congestion management. That's exactly what we did. On the left, you see close to Amsterdam on the map, you see a small dot. That's where the pilot took place. So it's not actually in the city of Amsterdam, but it's close to Amsterdam in the Amsterdam region in the city of Haarlem. A couple of weeks ago, well, a lot of companies, especially charge point operators in the Netherlands, were a bit concerned since grid operators stayed in responsible for a lot of cities in the Netherlands, published a news item that said, hey, you cannot charge your vehicle anymore between 4 and 9 every day because the grid is full. This was the solution of Stedin, to deal with grid congestion caused by electric vehicles. So a lot of charge point operators were a bit concerned because this would impact their charging station, their services, and of course also this would impact EV drivers quite a lot. And charge point operators said together, well, this is not a real smart solution. Just simply shutting off charging stations is not a smart solution. And within use case 1A of INCIT-EV, we have tested and proven a way more smarter solution than just shutting down chargers. We have tested and proved that smart charging can also work for grid congestion management. And I will show you how we did that. So these are some highlights of the demonstrator of use case 1A for INCIT-EV. We've used 200 public charge points in the city of Haarlem. On the right, you'll see this is the map where all the charge points were located. And on the far right, you will see an overview of how high and medium voltage cables are running through the city of Haarlem. And so in blue is the high voltage cable, in yellow the medium voltage, and of course low voltage is not not shown here because those are way more cables. We have selected 200 charge points that were fed by 2 substations in the medium high voltage grid. And the technology that we applied is passive smart charging. Now, passive smart charging means that there is no user interaction. So we don't ask people to join our smart charging use case. Smart charging is always available on the charger. So if you plug in your vehicle, you will get a smart charging session, whether if you like it or not is what we say. But if you really have, for example, priority, if you're in a hurry or you don't want to participate in smart charging, you can put a priority request via an application provided by Greenflux, and that is sort of an opt-out button. So then you will not receive a smart charging session, but you will always be charged as fast as possible within the limitations of the charge station. The steering window, so when was smart charging applied, was between 6 and in the afternoon and midnight. And we performed a final demonstration in October and November 23. And the results is what I will show you today. Within the final demo, 400 charging sessions were actively steered, and we have shifted 1 megawatt-hour of load to prevent grid congestion. And the partners we did this with are MRE Electric, that's the client. MRE Electric is responsible for all the municipalities in the provinces of North Holland, Utrecht, and Flevoland, and they cover electric charging for all the municipalities in their region. Of course, Total Energies, we acted as a charge point operator. Greenflux was responsible for the algorithm that steered every individual charger. And gemeente Haarlem means the city of Haarlem. That's where the pilot took place. And we're very happy to work together with MRE and city of Haarlem for this project. So what did we do? We used aggregated flexibility. So the 200 charge points were registered as one specific group to provide grid congestion to provide congestion management. So we've basically grouped the chargers, and our congestion service provider used this one group as one asset to provide congestion services with. Now, how this works is that the grid operator requests a power reduction for the next day. They place an order via the GoPax platform. GoPax is a trading platform for congestion services in the Netherlands. And market parties like charge point operators, we can offer the flexibility via this platform. So, a grid operator requires or requests, for example, a reduction in power for the next day. To say, hey, tomorrow between 6 and 7, you should reduce your power, or who can reduce power? And we, with this 200 charge point, we say, well, we can do this, and we will put a price on that, and the DSO will clear this order and will pay the price that is requested. Now, there are some specific rules for this. So if your order is cleared, you should deliver your reduction. And if you don't deliver, you will pay your congestion imbalance. So that's a real good method of actually providing your service. And since the grid needs to be in balance all the time, within the area where we apply smart charging, we reduce a certain amount of kilowatts, and that means that outside the area where we provide the service, somewhere to maintain balance in the grid, a party should increase their power demand, and that remains the balance to grid, and the grid operator will pay the difference between both prices that both market parties will request for this service. More explanation on how this works can be found via GoPax platform. There's too limited time today to explain how this service exactly works, but it's good to mention that this is a service that's really ready for market parties to use to provide congestion service. However, the fact that we have used an aggregated group of chargers, so 200 grid connections, 200 charge points, and we used it as one, that's really unique. It was the first time that this was used via this platform. Normally, data centers or wind farms, those are active on this platform, but it's really uncommon that low voltage grid connections for charge points are used. So this was really interesting about this pilot project. So the reduction results in a power set point for the entire group of chargers. And in most use cases that we have tested, we have used a 100 kilowatt reduction. So we provide our forecast for the next day, and then the grid operator says, okay, but then reduce it with 100 kilowatt during a certain time slot. And all the individual chargers were steered using the Greenflux algorithm. And the goal of the algorithm is to reach a set point without interfering the EV driver's mobility needs. So people should not know that smart charging is active. Of course, it is communicated via, for example, stickers on the charge point and an FAQ on the website. However, Greenflux steers the chargers in such a way that we get a large impact on an aggregated scale, but on lower level, the individual e-driver does not really notices that his charging session is happening a bit different. So this is what Greenflux does. They receive the aggregated set point on the left. So in orange we see the forecast. In green we see the load that is required. And Greenflux then makes sure that every individual charge point is steered. And they use all kinds of parameters to steer this. So how long is the session already active? How much energy is charged? How much actual power is the EV taking? Some EVs do 3.5 kilowatts, others do 11 or even a bit more. They take all these parameters into account and create the best charging experience for every individual connected EV in the aggregated group, so that the EV driver is impacted not so much, but on an aggregated level the impact is larger. So they start with receiving the set point from our side. They send a control signal to the individual chargers. receive measurements on how much power the EV is actually taking, and then they start the calculation for the algorithm. So how do we optimize this charging session? Another property of the algorithm is to protect the constraints. So the algorithm takes over the full functionality of the charger. That means that the algorithm also makes sure that the grid connection, which is usually 25 amps, is not exceeded. So the algorithm cannot allocate more than 25 amps to the entire charging station. All this is taken into account. And of course, if an EV driver requests priority via the app, the algorithm also calculates a more optimized profile for the charger, so that this charger is not really optimized anymore, but just gets full power. So to conclude, I want to show you 3 results. Those are 3 examples of the final demo that we did. 3 days. On day 1, we did a reduction of 100 kilowatts. The lower limit of the charge is 0 amps, so we are allowed to sometimes stop the charging session for a very short period of time. It took 1 hour, and as you can see here in yellow, I'm not sure if you can see my cursor as well, but in yellow you see the bit that we put in the platform, and in black is the steering signal that we send to the group of chargers, and you see that there's an actual reduction in power achieved. However, a very small red dot after our steering window occurs, and that's because, well, when you reduce power for 1 hour and then you stop reducing this power, all the EVs that are connected to your chargers will start charging. This can create a new peak in the electricity grid. That's why on day 2 we decided to try to reduce the peak that happens after your steering window. So that means that our steering signal took a bit longer after the steering window, and you see here that we are really able to prevent this new peak. However, when we stop steering almost at midnight, then you still see that the new peak arises. However, the peak is way more smaller than it would be in the congestion period. And yeah, a small peak at midnight is not the greatest challenge for a grid operator to deal with. And on day 3, we did a longer steering window, so a steering window of 3 hours. And there you can see again that after three hours of steering, you will definitely get a new peak in the electricity grid if you don't apply peak shaving afterwards. So that was one lesson that we already learned. After a steering window, you should always apply peak shaving to prevent a new peak in the electricity grid. More results will be available in the final documents for INCIT-EV. So to conclude, we have proven that aggregated flexibility can be used for congestion management services on public chargers. You need a decent group size, so we use 200 charge points, and that's really the minimum to make impact, but also to make impact for the DSO, but to minimize impact on EV drivers. And yeah, when using the GreenFlux algorithm, we achieved a minimum impact for individual EV drivers. We received about 2 complaints or questions, people who ask, hey, my session took a bit longer than usual, how come? And we could explain, well, we apply smart charging on this station, and yes, it can make your session maybe 30 minutes longer than usual. And we have seen that vehicles that charge with one phase and have a large battery. Examples are, for example, the Jaguar I-Pace. It has I think it's a 60 kilowatt hour battery, but on a public AC charger, it only charges with 3.5 kilowatts. So even when you don't apply smart charging, the Jaguar requires quite a lot of time to reach a full state of charge. And when you then also apply smart charging, and if the Jaguar has to share a charger with another car that is taking power, then the sessions on those specific type of vehicles are impacted more, and those people will really notice that smart charging is taking place. And a possible improvement for us and for GreenFlux is to take the phases into account in the algorithm, and not only the power that a vehicle is using, but also actually how much phases a vehicle is charging. So that's one possible improvement that we have discovered. I would like to leave it with this. Thank you very much.
Thank you very much, Bram. very nice and interesting because I believe that we are most used to hear about this in households. So applying this algorithm on a public stations is a game changer. We have a question from the public, but I believe that it has already explained by you in the last slides. If how long more time does it take for the client to charge, and if you get a lot of refusals from clients in a hurry?
Yeah, so the amount of priority requests is really limited. I don't have the exact number here, but yeah, since the impact on the individual driver is so low, people don't notice that smart charging is applied, or they accept that their session takes maybe 30 minutes longer, because that's what we're talking about.
Okay, we have another question. You mentioned that you shift 100 kilowatts per hour, sometimes 1, 2, or even 3. From an economic perspective, is it right to assume that co-packs clearing pricing are not high motivating enough to run this? Perhaps I'm wrong. Question.
Well, it's a market-based. It's a free market, right? So the prices, are determined by supply and demand, just like in any market. So it really depends on how much other players are active in the specific region that you apply this technology. And also, they're a bit influenced, of course, by actual energy prices. If you have a lot of competitors in your area, so a lot of companies who can offer flexibility, that will impact the price. On the other hand, you could say if you're the only active player, that you could just ask whatever price you want. However, for this pilot, we made some agreements with the DSO on pricing, since it was a pilot. But yeah, really depends on the amount of players, and it's a bit too early to conclude if this technology, or so congestion services, are more interesting than, for example, day-ahead steering or imbalance steering. We're currently running more pilots that look at other forms of smart charging, so imbalance markets and day-ahead markets, to see what's the most feasible. But most interesting, of course, is to stack those services into and combine it, so that you as a company can profit, but also the EV driver profits in the best way.
Okay. Excellent. And one final question. I don't know if you can calculate that now, but what was the total power capacity of the charging pool? What maximum share of total power can be offered for flex without impacting the final user?
So that last remark is important. Normally charging stations are connected to a 3x25 grid connection, so that results in 17 kilowatts in power per station. We have used about 200 stations, so you can multiply the 200 by the 17 kilowatts, and that's the amount of power that this group could take from the grid in total. However, of course, you're dealing with vehicles that take less power because they're one-phase vehicles. You're taking into account the amount of vehicles that are charging simultaneously. So we have an average occupation rate of about, I think, 30 to 35% on our public chargers in peak hours. So all that sort of things you should take into account to determine how much actual flexibility there is, so how much power there basically is to play with. But the group size that we have had here with 200, that's really the minimum to use to make impact on an aggregated level, but to prevent the impact on individual EV drivers.
Excellent.
But if you send your maybe question afterwards, I can have a more detailed look into it.
Thank you very much, Bram, from this very nice presentation, and thank you for all the people with these questions. Feel free to still writing questions, as we'll have some time at the end of the project and the end of the webinar, so we can still discuss these topics. Now, let's move to the next panelist. So we'll move to the block of bidirectional charging, AC versus DC bidirectional chargers. And we will start with Robin Berg. and with Antonio Muñoz from WeDrive Solar and Firfe, respectively. I will introduce briefly Robin. Robin is an entrepreneur and innovator based in the city of Utrecht in the Netherlands. He started in early of this century investing in solar power generation, and in 2008 he started solar power plants on school roofs in Utrecht city by starting interconnecting them with some of the EV chargers, and to be one of the first private grids in the country. This led him to establish in 2016 the company WeDrive Solar, of which Robin is the CEO. And WeDrive Solar has realized several international fleets in the field of directional charging in collaboration with car makers like Nissan, Hyundai, and Renault. So, Robin, thank you for being here today. You'll have right now more or less 7 to 8 minutes to introduce the results of the project in terms of AC, bidirectional chargers, and then we'll move to Antonio for the counterpart for DC charging and discharging.
Okay, Miguel, thank you very much for offering the opportunity to show some of the results. Let me share my screen. If not mistaken, you can see my screen now? Yeah, great.
Perfectly, thank you.
So yeah, we are really aimed at the development of AC bidirectional charging. We don't really believe that it's like AC versus DC. I think there's a different use case for both technologies. We focus on AC, and I will also tell you why. We started, as Miguel said, with installation of a lot of solar panels on roofs in the region, mostly school roofs, and did our first CHAdeMO bidirectional test already in 2013 in collaboration with Nissan. And this is a very nice test for us to see how the technology works. This was also my first electrical car, so great that we could also use it as a battery. But we soon defined that for scale up in a city like Utrecht and other Dutch cities, AC bidirectional charging is for us the way forward. So in collaboration with Renault, we first deployed AC bidirectional charging based on the AC 15118-20 standard, which was at that time still a draft. But we were able to successfully deploy this technology at a public charging station, and gave us the opportunity to roll out this technology all over the Utrecht region, to really solve a bit of the chicken and egg situation that there are not so much chargers yet that can support AC bidirectional charging. And the next step was that we also collaborated with Hyundai, who provided us with 25 production cars that also support AC bidirectional charging if you have the right software. And WeDrive Solar was able, as the only company outside of Hyundai, to get access to the software and to run a pilot with these cars in the Utrecht region. This is still not the final version of ISO 15118-20, so still a draft, but it was a production car, so we were now able to run these cars in our daily car share operation to see how this works. So we were very helped by the INCIT-EV project to have a test site in Oudijk, a housing project with a lot of renewables, as you can see, and also the aim to lower parking norm. So we were able to deploy the car sharing here and do smart and still a bit limited bidirectional charging. And we're able to test and also see how people in this neighborhood react to these kinds of concepts. And we also, and this is still ongoing, are testing the technology at the main office of Triodos Bank. They have built a new, very sustainable head office with, in the back of the head office, a large charging plaza, which we installed our equipment, covered with solar. And we are going to test in the coming months also with the final version of ISO 15118, which has been finally made final in 2022. So we can now start testing bidirectional charging and get ready for rollout. And for this rollout, we are also joining forces with MyWheels. MyWheels is the largest car sharing company in the Netherlands with a huge fleet all over the country. They are active in a lot of cities. And they basically said we want to adopt the model that We Drive Solar has developed in Utrecht and Odijk and other locations. So this model will be available with station-based shared cars, with We Drive Solar charging stations, with smart and bidirectional charging as the car support this. And they basically said, okay, we want to charge all of our cars at the We Drive Solar charging stations. So starting in Utrecht, our fleet of 200 cars has been transferred to MyWheels. And the 200 cars that were already available in the city with a free-floating model are now all station-based. So currently there are 400 station-based electric shared cars at We Drive Solar charging stations in the city of Utrecht. And this model is now ready to be copied to other cities in the Netherlands. So at housing projects like Odijk, but also others, but also in the cities like Amsterdam, Rotterdam, The Hague, Eindhoven. To give you an idea, in Amsterdam, MyWheels has more than 800 shared vehicles. And the interesting thing about this is that with this size, you can actually provide also solutions for grid congestion. If you have hundreds of shared vehicles in a city that support bidirectional charging and support smart charging, you can lower the level of grid congestion and help the energy transition. At the same time, this concept can help make electric car sharing profitable. So the results we have from this project and also other projects show that smart charging and bidirectional charging on a station-based car share solution for electric car sharing really lowers the cost for the car sharing operator and can really help to make it profitable sooner, which is something that is quite needed, I have to say, for electric car sharing, as a lot of electric car share initiatives fail because of high costs and operational costs. So for us, these are very important lessons we get from this project and really gives us the basis to scale up. This is just, as already Bram showed, ways how to make money with smart charging. This was yesterday in the Netherlands. So you can see the moments where we will be charging and discharging. So energy prices is really interesting as the number of hours with low and negative energy prices is really growing rapidly. You can see here in 2022, there were 34 hours with prices of 0 and below. Last year, 525. So the impact of renewables really has also an impact on price and of course on grid congestion. And as Bram also already showed with smart charging and with bidirectional charging, you can really lower the amount of grid congestion on, for example, trafo stations operated by the grid operator. So that's basically our story from the project. And I hand it back to you, Mikael.
Thank you very much, Robin, for this very nice presentation. In the end, the last part of your presentation is very nice as we need to know what is the pricing, also what are the revenues that as user or as operator of the fleet can obtain due to the changes in the tariff, in the dynamic tariff of the spot market, and also how EV users and EV owners of the fleet can obtain revenues that after the presenting these technologies is what we need for the rollout, massive rollout of this technology. We will keep questions for later. Now I will introduce my colleague at CIRCE, Antonio Muñoz. He's the Power Electronics Team Leader for EV Technologies at CIRCE Technological Center. He joined CIRCE in 2019 and has a background in design power electronics, specifically in inductive and magnetic energy transfer system. And he will introduce now the bidirectional charger developing INCIT-EV project. So the floor is yours, Antonio.
Okay, thank you. Thank you so much, Miguel. Good morning, I'm Antonio Muñoz from CIRCE and the leader of use cases. Use cases in this project is devoted to the low power DC bidirectional charging infrastructure for electric vehicle, including 2 wells. The objective of this use case was the design and the construction of a V2G demonstrator here in Zaragoza. CIRCE count with the support of INEO and Zaragoza Council for the development and installation of a V2G electric vehicle charging station, including the light electric vehicle. This use case was installed in the Expo area here in Zaragoza, near the Mobility Museum located in the Pavilion Bridge. During the INCIT-EV project, an innovative smart EV charger with advanced capabilities was developed. The V2G charger was designed to provide ancillary and flexible service to the electric grid, supporting grid stability by regulating frequency and voltage. This V2G charger can provide energy from the EV battery to support peak demand or balance photovoltaic generation in a building. The technology can also provide a STATCOM feature, supplying reactive energy to stabilize the voltage and improve the power factor. It is also able to balance phase to reduce losses generated by unbalanced lines. The EV charger can provide a STATCOM service with and without electric vehicle, making EV charging infrastructure an active resource for grid support. This EV charger is a modular, scalable, flexible, and cost-effective proposal. The charging station is internally divided into a 25 kilowatt AC-DC converter and two 25.5 kilowatt DC-DC converter. This topology adds advanced possibilities for the converter states to increase the output voltage and current. The V2G EV charger can supply energy to vehicles as a conventional charger. They convert AC grid electric into a DC voltage suitable for charging batteries of electric vehicles. The demo prototypes support both standard communication, CCS and CHAdeMO, and also provides a DC bus for charging 2 wells vehicles. In addition, V2G EV charger can take energy from EV batteries and feed it back into the grid. Thanks to this technology, EV batteries can be used as energy buffer to balance the intermittency of renewable generation and support peak demand. This technology is not limited to the grid. It's also suitable for vehicle to building to help save peak demand and stores building photovoltaic surplus, or vehicle to vehicle to alleviate grid congestion during fast charging. Furthermore, V2G infrastructure can provide additional support to the grid. An electric vehicle V2G charger can be a key asset for grid support, incorporating static synchronous compensator, STATCOM features. These features are not required to have an electric vehicle connected, allowing the charger power electronic to be utilized during any contingency. Currently, the demo pilot can provide reactive energy to stabilize the voltage and improve the power factor. It is also suitable for balancing active power in an unbalanced grid, minimizing losses and power failures. And in the future, V2G charger can provide additional features to support grids during fault condition or contingency events, or to provide dynamic harmonic filtering. The V2G power electronics developed in the INCIT project provide advanced vehicle-to-vehicle capabilities. Thanks to the flexible converter configuration, it can transfer energy from one vehicle's battery to another, regulating the DC bus internally. This provides flexible and efficiency in power conversion. This figure illustrates an example of V2G and V2B functions provided by the EV charger. Initially, vehicle 1 is connected and the charging session begins. In the second period, energy is supplied to vehicle from the grid, but grid congestion is detected. Then, the second vehicle is connected to provide grid support. In the third period, vehicle 2 provides energy to charge vehicle 1 and also to the grid to alleviate peak demand. In fourth period, the grid doesn't require more support, but energy for charging vehicle 1 continues coming from vehicle 2. Finally, in period 5, the grid congestion disappears, and the energy required for charging is provided by the grid. Thanks to the technology developed in INCIT project, CIRCE is participating in an industrial scale project led by Acciona Energía. Acciona Energía has established the Vehicle-to-Grid Balearic Island project, which has created the first bidirectional electric vehicle charging network to operate in Spain. The ecosystem is 100% renewable and enables the use of the electricity stored in the batteries of the electric vehicle for self-consumption or to inject it back into the grid. The V2G Balearic Island demonstration project includes 8 Balearic companies that install 16 charging points, 6 of which will be provided by CIRCE. Acciona Energía has provided 8 electric cars with V2G technology to participant entities. This car also be used as a storage system for self-consumption or to feed electric back into the grid. This pilot project is the first industrial scale implementation of V2G technology here in Spain. It is of sufficient size to establish usage patterns and behaviors. The conclusion drawn will help to advance the technological and economical maturity of this energy service model. Okay, thank you so much.
Thank you very much, Antonio. Very nice presentation. We've seen that V2G is possible right now, mainly from both sides. What we see that is preventing the massive uptake of bidirectional capabilities is the release of the ISO 15118-20 standard on commercial vehicles. So this is what is preventing the full scale demonstration, and this is why we are still speaking about pilots and not full scale demonstrators. This will be probably a topic for the next panel, as we'll have their automakers involved. But first, we have a question for this this panel. Do you have measure, and this applies to both, the losses for a whole charging session? So in the end, this is to know what is the efficiency of the charger when charger and discharging. Just as a general comment, for AC bidirectional charging, the charger is on board the vehicle, and for DC bidirectional charger, the charger is outside the vehicle in the stall, installed in the street. But in the end, they have the same capabilities, but of course efficiencies can change. I don't know if any of you have this information about efficiency or power losses during the charging sessions.
Yes, we did a round trip study with the Renault Zoe. So then the chargers, the bidirectional charger on board the car. This is already data from 2018, 2020. And that came out of a round trip efficiency of 85–86%. So we were quite happy with that. And we are hoping that the new Renault 5 will have the same kind of level, even lower. Yeah.
Excellent. Thank you, Robin. let's hope that in the coming months we can obtain that efficiency also from Hyundai. In this case, I believe that for each automaker it will be a change of efficiency due to different onboard chargers used. Antonio, do you have such information for the DC chargers?
Yes, I think for off-board charger, we can make some micro DC grids with photovoltaics available in the buildings, and we can have a very big efficiency. For example, for our DC-DC converter states, we have an efficiency about 96-98%, depends on the voltage of the battery, and then we can provide a very high efficiency in the conversion. I think we have a lot of synergies with photovoltaics in buildings and DC microgrid with this kind of EV charger. Yeah.
Okay, so I understand that the round trip, so charging and discharging, will be around 90% or 92%,
Yeah.
considering both
The battery.
efficiencies.
Yeah. Yeah.
And the efficiency on the battery. Okay, excellent. Thank you very much. We'll move now to the next panelist, but we'll have you again on board for this last debate. So you can still keep your camera on. Also, Bram, you can join. So I will present now our panelists from Stellantis and Iveco. Let me first start with our colleagues from Stellantis. We have today Olivier Boutas. He works in the charging ecosystem innovation pilot and works in the customer experience of the domestic grid. We have also Damien Pierre Sanflot, who works also in the charging ecosystem as a project leader, also for smart grid. And from Iveco, we have Gianluca Donato, charging ecosystem lead engineer, responsible for charging and grid integration technology roadmap development that is also involved in project related with interoperability and second life batteries. Let me put you on first plan for everyone. We are right now 70 people connected. So thank you for all of you for being today here. I cannot find your images. So I will start with the questions, and then I put you on the first screen. So first of all, maybe we can start with Stellantis. A question for you is what are the plans from your side in terms of bidirectional charging? I know that you are working right now in some pilots. So how do you see V2G, and what are your plans to see in commercial vehicles bidirectional charging?
The assumption possible would be from 2026. But we are very careful by talking on the different price on everything, because the use case is defined, but that's a huge topic. I would say that we are working for customer, and the customer is the owner of the car. So all the thinking we are around this topic is what the end customer wants concerning V2G. And nowadays, he don't want so much. So I would say that according Stellantis, till now, the topic is not mature enough on business point of view, means perimeter point of view. One topic, for example, is the efficiency. Just during this excellent webinar, we heard a number around 94, 93, and we heard also a number of 86. As you could imagine, that's a larger spectrum of answer. So yes, we are very careful. Maybe Damien, you could help me to position Stellantis.
Yes, thank you. As to complete, thank you, Olivier. To complete the Olivier statements, as we can imagine, the efficiency is a key success factor for that point, and it depends on the profiles, the system design, and so on. But we still convinced in Stellantis that there is place for V2X features with clarified ecosystem design, and even for B2B or B2C for fleets, and even AC or DC. As Robin stated, we think that the use cases can be very open to this AC or DC solutions.
Okay, thank you very much for this first question and answer. Maybe I can have the same question with you, Gianluca. Iveco Group is maybe more focused on industrial and commercial vehicles, so maybe the business here is a little bit different. So same question from your side. How do you see from Iveco V2G, and what are your plans for V2G in commercial vehicles?
Okay, thank you for the question, Miguel. Well, Iveco is working on V2G functionality introduction in its product line at, let's say, at the R&D level. You know that we are part of this INCIT-EV project, and we also running a demo site in Turin, where we are going to demonstrate these V2G functionalities. Particularly next week, we will have, let's say, this demonstration in Turin, where we'll demonstrate the functionalities of this charging hub with low power DC bidirectional chargers that will be connected let's say, in a very specific environment, because will be connected to a tram line. So probably most important use case to investigate there would be related to the recovery of energy from the train line braking. But anyhow, we would like to leverage also on the V2G technology to see whether we can work on use case like the one that our colleagues showed before, where there are kind of V2V functionalities in place. So we are working along that journey, that we bring, let's say, these functionalities into our product lines. There is interest for all the product line, like commercial, truck, buses. And this is a journey. So we do expect that we will have commercial feasibility into 25 or 26. But as our colleagues were mentioning, there are still a lot of topic to be clarified on the technical side and the commercial side.
Okay, I thank you for the statements. I see that it is a complex topic for automakers to have an early release for this. One topic from the user perspective, usually an user, let's see that the first application that they may want to have is to have an electric vehicle to be charged at the lowest cost from the grid. And then in some cases, especially advanced users that are still are using now photovoltaic systems, they want to use their car as a vehicle to home, at least to provide some energy for their own appliances at home, maybe not to sell this energy into the grid, but to reuse, to use their electric vehicle battery as an storage for their own household, as a start of what we see that will be the electric vehicles in the future. Do you have, as an automakers, any concerns on how this V2G might affect on the warranty of these vehicles, or if or maybe that the low power output in comparison with the driving will barely affect the life expectancy of the battery? I don't know, you have any information or comments concerning this topic from your side?
We don't take the problem like this. The warranty for our customer is not a question. So of course we are going to warranty the battery for the 8 first years, surely. So we are going to monitor, I would say, the V2G part. Then this is a question. If we monitor, how could we do this? Are we checking the information over the air straight to the car? Are we going to allow a third party to use the V2G? We don't answer. We don't know. But
and especially under which conditions that we can, of course, contractualize. As Olivier said, warranty for final customers in the question. We will keep it on our B2B perimeter side, and then the question is how to spread the additional cycling, if there is, and to spread the value associated to additional aging if there is.
Okay, thank you for that. Let's cover one of the questions that we have from automakers. Do you have any preferred topology, AC versus DG V2G charging, or do you plan on offering both options to your customers? This is a topic, a decision in the end to include on board a V2G charger, or to rely on the CCS connector for external charger. I don't know if any of you is able to answer this question.
Maybe I can try to answer on my side. Let's say for the time being, we are on our side, we are specifically focusing on DC charging. Also because, you know, for commercial vehicle, it is in some case for, let's say, most application, probably not so needed an AC onboard charger. If I think about buses, they do not have AC chargers, they only charge DC. And we are thinking about trucks where probably will be not so relevant to have AC charging. So because our kind of vehicle is shifted on EV vehicles, and the AC charging application seems to be not as relevant as passenger car. We are for the time being focusing on DC charging, prioritizing this. Then there is also the grid compliance topic, where we have the feeling that will be quite hard to manage on the OEM side. And would expect that a DC charger that is installed somewhere, it is much more easy to be compliant to a specific grid compliance code.
Okay,
Yeah, maybe.
Yep, Rory,
maybe
please.
To add from our experience in this project, we are now working together with car companies for almost 10 years on bidirectional charging. And this is, of course, based on the cars, not on trucks. And there we see now a bit of trend towards AC, but also DC is still happening for cars. But from the client perspective, like people parking in the street or companies building charging plazas for their employees coming to work, we see that AC charging is the easiest way forward concerning scaling up and the room it takes and the costs. So we take the for AC, you also, as in a DC charging station, need to have grid compliance. So yes, an AC bidirectional charging station will also have to have some grid compliance features. So I think it really depends on the use case. So I really don't hope it will be like a war, like you see a lot of standardization wars in the past. No, I think it will just be, as Gianluca also mentioned, I mean, for trucks, AC doesn't really have, in buses, added value. But for the large rollout with cars, I think AC bidirectional has also a huge opportunity to really scale up bidirectional charging using cars.
Excellent. Thanks for the discussion. Indeed, yeah, it's true that you don't have a onboard charger based on AC. Of course, everything will be based on DC for these industrial heavy load vehicles. So this use case will be totally different. Let's go back to smart charging, trying to link to this discussion. This question is more for you, Bram. At some point, being able to participate in congestion schemes and being able to have, let's say, a lower cost for charging out of the peak hours, it will result somehow in cost reduction from the point operator. Do you plan to include a price reduction or dynamic tariff for EV users that are using these charging points with flexible charging times?
Yes, that's definitely part of our ambition. We see a lot of requests for this as well. A lot of EV drivers or consumers in the Netherlands are more aware that energy prices are different throughout the day. You can now contract hourly contracts at your house, for example. So yeah, the question towards charge point operators is often, hey, why is this not offered yet on public charge stations? Maybe some of our competitors do it. I'm not sure in the Netherlands. I don't think so, to be honest. However, since we deal with public charge stations, the charge point operator in the Netherlands is typically not the owner of the charge station. The owner is mostly the city or municipality where the stations are in, and this owner is also the one who decides on implementation of dynamic tariffs, etc. So we set a tariff, but yeah, the strategy, if it's a dynamic or fixed price is also defined by the client, so the city or municipality. So we're not completely free to do whatever we want. Then there's the other challenge of the market model in the Netherlands, or I think that's quite common in Europe, where you have the role between charge point operator and e-mobility service provider. So usually the EV driver has a contract with its e-mobility service provider, and it's the e-mobility service provider, so the party who gives out the charge cards or the charge tags, that sets the price for the EV driver. So if we as a charge point operator decide to implement dynamic tariffs, that means that the CPO tariff on our charger would change and would be different. However, we don't have the guarantee that the e-mobility service provider will also put this tariff towards the end user. So there are a couple of challenges there, but this is definitely a topic in the Netherlands, together with price transparency, and I expect to see the first implementations on public chargers in the coming months or years. Definitely, maybe not throughout e-mobility service providers, but then, for example, throughout direct payments on the charger, where you're always guaranteed on paying the charge point operator tariff.
Very interesting, Bram. Yeah, it's true that roaming and the use of mobility service providers can offer different prices. Sometimes it can be illogical, as the mobility service provider can offer a lower cost than the one who owns the charging point, or it can be the other way around. So it doesn't really match with the reality. But yeah, it's true that this is a concern from citizens, in which you see on the news negative prices and say, why I cannot charge under this time, and to have a lower cost, as I'm helping the grid to use this excess of renewable energy. Robin, maybe a question for you. Smart charging and control via control pilot in the charging stations, in the public charging stations, has been available since the very beginning of the electric vehicles. Some models of electric charging stations from final users at their homes have this dynamic power balance with the knowledge of how much are you consuming from your house, so you can have this smart charging at house level. But why at public level this do you think that this has taken so much time to be applicable on public charging stations in generally? And I don't know if specifically from your case from We Drive Solar, if you have applied this in the past, and since when?
Yes, well, on our chargers we have only dynamic energy contracts. So we really want to steer the charging towards the moments that there's most renewable energy in the grid, which is often the cheapest moment. And it's good to realize that something quite, I have to say, bizarre has happened in the Netherlands. I mean, the Dutch completely went crazy with renewables in the last few years, and that's we were like one of the countries only just a few years ago lagging behind in the European levels of renewable energy. And to give you an idea, the Netherlands is now the #1 country with solar panels per inhabitant. So we have even more solar panels than Australia. So per inhabitant. So that's, you have to imagine what happened. So there's a massive amount of solar, there's a massive amount of wind also still being built, especially at the North Sea, in the coming years. And this has really impacted our energy prices and caused a lot of grid congestion. So now the Netherlands is also, and you see it also in Spain, the prices are suddenly dropping off the cliff. And that really gives a lot of possibilities to really scale up the smart charging concepts, and really focus to bring the charging at the lowest price levels, which is now for 99% also the moment when there's a lot of sun and wind available in this country, and at the same time reduce the grid congestion. So we did this already at the public chargers we have, but the great thing about the combination with car sharing is that you're not limited to the rules of the concession for the public charging infrastructure. So there are a lot of contracts for public chargers that limit the amount of things you can do. And thankfully, for example, in Utrecht, with where also Bram and Total Energy is involved, there's now a first new tender where also dynamic pricing for the end user is being made possible. So I'm very happy with that. But in most contracts, that's not possible yet. You have fixed tariffs that switch sometimes, but not on an hourly basis. Definitely not. So with our car share fleet, we were able to go a lot further, as we don't have to comply to this contract and can basically do what we want on those chargers. And that also gives us the possibility to really test dynamic charging, based charging, test bidirectional charging, and also stop charging completely without interrupting the car sharing service, and really optimize smart charging in such a way that both the car share operator and the grid and the renewable energy transition profit in a maximum level.
Excellent, Robin. Good news to hear from your side. A comment from Karima Bukir. Following market prices might end up with higher local constraints. It's true that at national level you might have this excess of renewable generation, but how can you couple this renewable generation from origin to the demand? This is true that in this case, on this topic of this webinar, we are speaking about electric vehicles, considering that they are a manageable demand. So this is why we are discussing this. There are other demands that are not manageable, but in this case, we have some flexibility. To any of you, what you're feeling about this? Following lower prices might end with the local constraints somewhere. This is not something good to follow, or there should be any additional restrictions for this.
Well, from our project, we work closely together with the grid operator. So Stedin is also a partner in the projects we do. And so we always check grid congestion limits. So the local grid is, of course, the fixed barrier of what you can do with smart charging. And now finally, these grid congestion markets also are slowly adopting EVs as maybe also a threshold that can help lower congestion. But the main result from this test was that if you look at day-ahead prices and renewable energy availability, you're often at the right spot helping the grid operator. So 99% of the cases you are helping. And as Bram also showed in his presentation, sometimes you have a peak afterwards. So we have to maybe prevent that peak by lowering the charging levels after a lowering you have done. So yes, so the grid operator in general is very happy with what we're doing. So there we are basically helping them, especially when bidirectional charging comes into place. Then you can not just lower what you do on the grid, but also provide power when there's actual congestion happening. So if you look at Miles, for example, they're now heavily into the market of buying cars that can provide bidirectional charging on AC. So please, car makers, come with the cars that support this, and you will have a huge client in the Netherlands. And I mean, they have like 3,000 cars in operation, and they want to make that fleet bidirectional in the coming years. And they're not the only one. So this is a huge opportunity, I think, happening in the market. Yeah.
Thank you, Robin. Very clear. Maybe for Stellantis or Iveco, what do you think that is right now preventing the rollout of the ISO 15111-20 standard in the vehicles? Because we saw that CHAdeMO was available 10 years ago, so it's not a technology problem; it's a problem of communication and interoperability. So, what do you think that right now was and are the existing barriers preventing the V2G full scale deployment?
I can answer if possible to have a clear answer on that. Definitely, maybe I will lead my colleague of Iveco complete. Today's 15118-20 ISO 15118-20 have a very have been published from 1 or 2 years now, and there is some testing chapters that still under completion. But I would say most of the technical elements are here and ready to deploy this type of communication. Some element which are missing is more about the the architecture of the system and the split of the features between, for example, the grid code distribution between the charging station and the vehicle in AC mode is not clarified, not stabilized yet. At least to do interoperable questions. This will be one of the points that has to be addressed. Of course, in DC it would be quite different. Another point is that normally you should have a cybersecurity environment that makes the trust existing and available between the charging station and the vehicle to know which one is doing what, and if it is a trustable partner that is plugged in, or try to take energy out of your car. And this will be a part of the PKI private environment or public V2G route that has to be used, and the group of certificate structure to be produced. It will be another, I would say, ongoing task that we have to complete to have a clear cyber environment for that. And definitely, as you mentioned, Robin, that there is a plenty of customers that would be very happy to do so. But as we mentioned, there is a question of the limiting the solicitations that has to be dealt with and clarified in order to be sure that for our final customers, a warranty will not be a blocking point regarding the aging of the battery.
Thank you.
Yes. I would add warranty and also the residual value of the car, because as you know, in Europe, there is the assumption of rules that take about I don't remember the name, but virtual kilometers. So we need to have a car that respects the warranty at 8 years, but also that the part of the stationary use of the car don't decrease too much the residual value of the car for the customer positioning, I would say. That is quite new.
Understood. Yeah, this is something that everybody needs to take into account, as it's a new use that it was not possible for petrol cars, and right now the window for electric vehicles is much higher and wider than it was previously from the vehicles.
Yes, I just want to add one detail concerning car maker. In France, for example, we try to have the smart charging behavior by default. And it could be linked with subsidies from the government. So we have a challenge, a technical challenge, that when you plug your car, by default, this is the smart charging is operate, even if it is through a third part, either a smart meter. But for customer, we have also to balance the things, because as you know, it's not so easy sometimes to sell an EV car to customer, because you want to feel free. So if you say, we are going to sell you an EV car, and by default, it's going to charge when he wants, when the system wants, and also we're going to use it for V2G, we have to be empathic with the customer to feel that he still feel free, because it is his car. On thermic story, it was really his car. So now the link is a little bit different with the ecosystem. So we have to take care of the feeling of the customer. This is car maker point of view.
Yeah. That's totally true, Olivier. And indeed, this is a quite complex topic. This is between professionals. We can speak about this, but this is very complex for the citizens. So not everybody is involved in the grid markets and in the changes by month and by day and by hour of the tariffs. So this is quite a complex topic, but in the end, what for the final user smart charging should be is something that they don't need to think about. that is going to optimize their daily charge, lowering the cost, and of course that they want the vehicle to be charged, to be available as the option as brand offer for Total to opt out this smart charging scheme in case that this night you want to have a full charge as you are going to depart tomorrow. But this nice information that you have shared, because we sometimes skip to the technical part and forget about the emotions from the final users that are suffering a transition that is not easy for everyone.
If I may comment
Gianluca,
on,
of course, please.
on Iveco side, let's say on the technical side, again, being at the time being more focused on the DC, we see the same major issues that outlined our colleague Damien regarding the PKI topic, the certificate environment, the management of the certificate within the ecosystem, and that is quite new, with a lot of detail about renewable expiration, verification, that are not so clearly defined, and probably there is a need for a little bit much more maturity at the ecosystem level, not only in the vehicle side, but also on the charging station side and the rest of the ecosystem. Concerning the warranty topic and the commercial topic, of course, as a commercial vehicle OEMs, we have a slightly different perspective. Probably it's not so important the feeling of the freedom for the fleet owner, but it's for sure a paramount the TCO. So everything run based on money. And so what is, let's say, blocking probably a little now today the acceleration on the V2G implementation is the fact that it's not clear what could be the benefits. There is not clear pictures about the offering on the market for V2G services that this fleet owner could provide to different kind of stakeholder, because we are talking about different kind of stakeholder. So it's very complex environment on the business model point of view, on the commercial point of view, with very few information about today. And then on the other side, there is a doubt about the cost that is for sure on the shoulder of the fleet owners, that is the cost of the degradation of the battery that has to be evaluated and taken into account. And this depends also about the kind of services that the vehicle will deliver to the grid or the building or whatever. Because I have the feeling today we discussed about a lot of service that bring value with the concept of the arbitrage managing, so the arbitrage within the energy market. So that means that you need to have a high level of throughput energy across the life, while there are other services related to that could support DSO or TSO management of the grid related to the frequency regulation that are not so impacting on the energy throughput point of view, but that are not so advanced in terms of services offering, because I see also a kind of decoupling of interest between who is taking the revenue, who is suffering the cost, because we all know that DSO and TSO will be happy for that, but we do not see what they are going to offer to the end user or to the fleet owner, to them, because there's no clear understanding of what kind of services this kind of player could offer to the end user. So this is a picture that has to be clarified in order to accelerate the V2G implementation.
Thank you, Gianluca. I believe that you hit the cornerstone question on pricing, on revenues, on that the service provided need to provide more value than the investment and the degradation of its use. So this, I believe, that is the high topic for V2G. We learned a lot today. We are going to an end of this webinar. I would like to thank all the panelists' involvement today. We see that, of course, charging at the lower cost and making use of congestion schemes from DSOs can help final users and also the DSOs in managing the local grids. We've seen also that we have capabilities of offering this bidirectional charging from AC side from the vehicle or from DC side from the chargers. This is still an open question of what will be more relevant in each of the specific pilots or use cases that will be developed in the next years. This is a very interesting topic, and I believe that the complex situation of dynamic changes in energy markets is going to exacerbate this debate in the coming months and the coming years. So it's clear that this debate is not ended. Thank you also for the participation of all the panelists, of Total, of WeDrive Solar, of FIRFE, of Stellantis, and of Iveco. Thank you for your insights as automakers, which is also very relevant as you are a very important key stakeholder in the value chain of the electric vehicle and this new business model for V2G and smart charging. And before I end, I would like just to remind that this was the first webinar now that the INCIT-EV project is ending. So we will in the coming days include the dates for the following ones. We will discuss about inductive charging. We will discuss about the user concern and specifically the revenues of the charging ecosystem, mostly also linked with today's discussion, and also with urban charging planning tool that has been developed in INCIT-EV. Also, I remind you that the final event of the project will take place in Paris in June. We'll be able to see also the dynamic charging lanes installed in this city. So with this last information, I would like to also thank all the attendees of this webinar. Hope that the information that we have shared was interesting to you, and we'll see you in the next opportunity of INCIT-EV webinars. Thank you very much, all of you.
Thank you, Miguel.
Thank you.
Thank you for hosting.
Thank you, boss.
Thank you for all of us. Ciao.
Ciao, goodbye.